Here in number 2, we have another continuous function on a closed interval. Therefore, we can apply the extreme value theorem to find an absolute max or min. So I took the derivative here and simplified for you. So now we need to find the critical values by setting this equal to 0. 0 equals -1 plus e to the 1 minus x. 1 equals e to the 1 minus x. I can take the natural log of both sides. This cancels, and I'm left with 0 equals 1 minus x. So x equals 1 is our critical value. So now that I know that critical value, I can sign check that derivative over that closed interval around that critical value. So to choose a number between 1 and 3, I can let x equal 2, and that plugging into my derivative is -1 plus e to the -1, which is -1 plus 1 over e. Well, -1 plus 1 divided by a number is still going to be negative. So since this is negative, I know my function is decreasing in that interval. In this interval, I can let x equal 1/2. Plugging in 1/2, I get -1 plus e to the 1/2, or -1 plus square root, not 2, square root e. Well, let's think about square root e. Square root e is going to be between square root 4, because 2.71 is less than 4, which is between square root 1. So square root 3 is between 1 and 2. So it's greater than 1. So -1 plus a number greater than 1 is going to be positive. So my function's positive. It's increasing. So from there, I can say by the first derivative test, there is a local max at x equals 1. So we know it's the local max, but do we know if it is the absolute max? Well, the way we check is by plugging in our local max and our endpoints to see which one's the highest and which one's the lowest. So f of 0 is 0 minus e, which is -e. So 0, -e is 1 point. I'll check my other endpoint. F of 3 is -3 minus e to the -2, which is -3 minus 1 over e squared. So that's 3, -3 minus 1 over e squared. And then let's check f of 1. Plugging in 1 here, I have -1 minus e to the 0, which is -2. So 1, -2 is a point. Okay, so which one is the low or the absolute min? The lowest y value here is this one. It's going to be a pretty big negative or bigger negative number than these two. So this is my absolute min. And then which one is the highest number? Well, -2 is bigger than -2.78. So this is my local max. Oops, not local. By the mean value theorem, it's our absolute max. So after we find our local max and min on a closed interval, then we have to check our endpoints to see where there's absolute max and mins.